Welcome to solverfy.
So there really isn't any way to do this by hand. You would simply have to plug in the all of the data values into Excel or MATLAB or any sort of graphing software in order to obtain a graph that sort of looks like this. And then you can use a bunch of different analysis methods in order to try to gain a best fitting line for this data. So part A wants us to use a quadratic fit. So using a quadratic fit within Excel, this gives us that the pressure of the quad would be equal to 3.9409 times 10 to the negative seventh y squared, where y is the altitude, minus 1.1344 times 10 to the negative second times y, and then plus 100.91. So that would be the formula, the equation for this line if we wanted to use a quadratic fit. Now for part B, they want us to use an exponential fit. So here it would be an exponential fit. And in Excel, they would give us P exponential would be equal to 103.81 times the exponential function of negative y times 1.339 times 10 to the negative fourth. So this would be the line of best fit if you were to model the function exponentially. And then for C, they want us to find the percent difference at 8,611 meters. So for part C, we should say that the pressure using the quadratic fit at y equals 8,611 meters. This would simply be equal to 3.9409 times 10 to the negative seventh, and then times 86,100 squared, and then minus 1.1344 times 10 to the negative second times 8,611, and then plus 100.91. And so the pressure using the quadratic fit of y at 8,611 meters, this is going to give us 32.45 kilopascals. For the exponential fit at y equaling 8,611 meters, this is going to equal 103.81 exp of negative 86,100 times 1.339 times 10 to the negative fourth. And we find that using the exponential fit, the pressure equals 32.77 kilopascals. So the percent difference would be equal to 100 times the exponential pressure, the exponential fit, the pressure using the exponential fit minus the pressure using the quadratic fit, and then divided by 1/2 times P exponential plus P quad. And so this is going to equal 200 times P exponential minus P quad divided by P exponential plus P quad. And so for part C, the percent difference will be equal to 200 times 30 32.77 minus 32.45 divided by 32.77 plus 32.45, and we find that this is equaling 0.98%. So both lines are very accurate. There's only barely a 1%, rather just under a 1% difference between the two lines, and that makes sense. We don't know what the true pressure is, so we don't know which fit is best for this graph here. However, the quadratic fit and the exponential fit do both give accurate values relative to one another. So again, that percent difference for part C is 0.98%. That is the end of the solution. Thank you for watching.